So today we discuss continuation of previous class. Create a image, okay, of a lens, with the help of lens or by the lens. So previous class we discussed how to create an image by a convex lens. Here we discuss how to create a image in a concave lens. Okay, the object and image in a concave lens. The object and image creates by concave lens. That's very important. So previous class I told that if you depending on your drawing skill or drawing ability, so there is a error, that is a maximum, that is a human error. Okay, and if I try to draw image and beautiful image, then I see the image carefully, then characteristics of image and application of the image, nature of the image, I think there is a error, because that time if you don't know what is the actual position of the focus, actual position of the object, so actually depending on line. Okay, so that's why I told you, please remember the table or the chart. Okay, if you do carefully remember the table or chart, first put an object, then play lens. So actually first place a lens, then object, then image, then a ray diagram, then joining by the ray. And that's the, I think, a correct way to drawing the ray diagram. So there is a chart by the concave lens. In ICSE physics, there is a just two position of the object, two cases. Okay, so position of the object in two cases. Okay, okay, and position of image. Position of image, just two cases. First, if object at infinite distance. So what is the position of the image at focus? Okay, and number two, so between the infinite and optical center, between infinite and optical center, in between, maybe I think center of curvature, maybe either maybe the focus, maybe the second focus, the optical obviously second focus. That's depending on the where he places the object. And when the create image create in between focus and optical center, focus and optical center. That two is very important. Position of the image. If you know the position of the image and position of the object, then easily you can define what is the nature of the image and size of the image and the application. Okay, that's very important. That's two things you remember: position of the object and position of the image. Okay. So when object placed at infinite, what is happened? I draw a diagram when object placed at infinite. So first case, when object places infinite. Okay, first we put a lens or draw a lens very carefully. That is a concave lens. Okay, that is the optical center. That is the principal axis, and that is the principal focus or f1. Radius of center of curvature C, or another name is f2, or twice f1 or twice focal length. That is the first focus f1 or principal focus, second focus f2, and f2 that is equal to twice the focal length, because the f2 is center of curvature. So what is the front of object and behind of front of lens and behind of lens? So front of lens means when place object, that's the where. If a object place here, that place is the position is of front of object, and that is the behind of front of object is front of lens actually. If a object place here, that is the front of lens. If a object place here, that is the front of lens. If object place here, that is the front of lens. So behind that lens, that is a behind of lens or opposite of object. Front of lens, behind of lens. If object place here, if object place here, that is the front of lens. Opposite side is a behind of lens. Clear? Very easy. Now we put a object at infinite distance. So that is the object at some infinite distance, long distance here actually. Okay, a long distance we put a object here. Okay, so the incident ray parallel to principal axis, and that is a divergence length. So the ray is diverged. So if I back this, so this ray passes from first focus. Okay. Now that is a head and that is a tail, or A and B. A place anywhere between this, either here, either here, either here, anywhere. Okay. So that's why we need another point. We need another point. So that's why we choose another point. So if I ray passes from A actually, so actually back to the say parallel to the principal axis, similar condition. So here are two cases. If incident ray passes through the focus, that is a refracted ray, or here the reflected ray passes parallel to principal axis, or if incident ray falls on an optical center, so they do not deviate. So we choose if incident ray fall on optical center. We choose very carefully optical center. There is a far infinite distance. And if you see that very carefully at that point, okay, so carefully you see that 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 is the head of the object. Okay, that cut point, you see the zoom that point here, you see the cut point actually here, and this cut point very near to the focus. Actually this object, if object is far behind that C, so you get that actually the place an object is infinite. You see that connection point, but meeting point actually passes the focus, and we need another line for bottom part if that incident overlapping the principal axis falls on an optical center. So similarly at the back, and you see that the head of the object here and tail of the object is principal axis place on. So A, that is a and here is a B. Okay, that is a two cut point is very needed. Okay, otherwise we can't tell where is the place A. That's why the two ray is very important, and arrow also important. We see that this object, object here, the object is infinite and the image is at focus. So image creates at focus, and that image is upright image. You see the head and this head both are in same direction, upward direction. Okay, that is not inverted, so that's why these are upright. And we see that if object here, there's a front of lens, image also created the front of lens, that image is called a virtual image, because screen obviously plays an opposite side of the object behind the lens. Actually there's a behind the lens, but the image cannot create on the screen. That's why this image is called a virtual image, and that is a size is very small. Size is very small, very small, or also called diminish. Very small. Okay, so application is Galilean telescope, making a spectacle for myopic eyes. There is another example. So that is the case of part B. Okay, that is the Galilean telescope is here, and part B. Let's see that when infinite optical center, that is a myopic eye problem, spectacle space. Okay, so is another important. See the very carefully. If these two rays If the object are placed at infinite, these two rays are parallel ray. Parallel ray. Clear? Next application is if object place infinite and optical center. Between, I think that's very easy to drawing. So first we put a convex lens, optical center, principal axis, principal focus or first focus, second focus, first focus, second focus, and object place, I think, and here you see that infinite to optical center, anywhere between these two. So easily we can object place here. Suppose we place the object here in center of curvature. Okay, so we need, if object is no height, that is the length of lens. Okay, so see the carefully, I think okay, so the incident ray, parallel to principal axis. The incident ray here, you see that parallel to principal axis. So that is a divergent planes. So that's also back to the focus. If a original diverge here, so back to this to the focus. I need another point. So if I can't find another point, I cannot tell where the point A belongs to. So that's why I need another point. So another, if a ray incident falls on optical center. So optical center. So that is do not deviate the passes through this. And if I that it passes through this as a mirror image like this dot line. But you see that very carefully. Actually, cut point we get here actually. So that is a that point is A, and if I incident falls on here, that back to these or same, do not deviate. If a incident falls on a optical center, so that means they do not deviate. So we get a point B. So point B is here, A and B. And same case, this condition, image create focus and optical center, between focus and optical center. Okay, between focus and optical center, between image creates between focus and optical center. Okay, and similar condition, that is upright, because that is same A and B. So why upright? These are called Y, positive Y, negative Y, positive X, negative X. If object is head is positive Y, and that is this line is leg, we create image in same positive Y direction. That's why these two are called upright. It is not inverted. A and A are the same direction. That's why they are upright. And that is the front of lens, means a virtual image. Okay, and number 4, smaller than the object. Okay, this is smaller than the object okay, and that's also called a diminish. Okay, the application is the making spectacle for myopic eye, you tell that. That's the two application of convex lens. Okay, characteristics and location of the image, we tell these are. Okay, now another important point here discussed, that is called a inference. So what is inference? Inference is a notice that irrespective of the position of the object, the image formed by a thin concave lens or called divergent lens is always a virtual. We see that the image is always in virtual, upright and diminished, smaller than the object, and it is situated the one side of the object, means same side of the object. So that's between focus and lens, because that is important, and that is called inferences here. means there is a same. Okay, if I place object here, that means they always these two are the same, because far difference. So that's why also to be the same is very small. It pass close to the lens, that is also very small. Okay, that is the inferences, both are the same cases. Okay. Now, the last is the difference between image formed by the convex and concave lens. Last topic we discuss in this chapter is difference between image created by the convex and concave lens. Very easy difference. Okay. See, that is a convex, that is a concave. Okay. So image is always virtual and the or in all position of the object. So image is always first here the virtual image. In case of convex, image either real and virtual depending on position of object. Case difference number 2, image is always diminished for concave lens or smaller than the object. But here you see that can magnify as well as diminish. But same case depending position of the object, and either magnified or diminish, same is depending on position of object. Number 3, okay, image is always erect. Is always erect. Yes, always erect. But here is the image inverted as well as image. So inverted as well as erect. The image is inverted if the object distance beyond the focus, and erect if the object is within the focal length distance. Okay. So if inverted or erect, it's a depending position of the object. Similar case, depending position of object. Okay. So that's the difference between image created by a convex and concave lens. That's our ICSE class 10 syllabus. Okay. And if you solve some question answer here in Newton book, or you can check in Google, you get some maximum number of worksheet here. Okay, you can solve these for your improvement. So next class we discuss sign convention and lens formula. That's a very important in this chapter. Okay, diffraction of lens is the lens in this chapter, sign convention and lens formula, and here is a huge number of numericals that is very important for board exam. Okay, you can get I think 5 to 10 marks in each and every year. So today end the class here. Thank you.